Hi everybody, this is a review in Calculus 2. We have this problem ranking the row rates for the following function. So we have 16 different functions. But before we actually do the problem, let's just review a few things. So we rank the row rate. So the row rate is where the function, how fast a function will go to infinity. It only goes to infinity. If it does not go to infinity, that will be the slowest. We're not going to rank those functions. And so a few things we need to note. So history notes. Important note. Number one. The scalar multipliers will not affecting the grade. Or say constant coefficient or scalar multipliers, not the same thing. Does not affecting grade. Does not affect grades. I'll give you two examples of this. You have like x to the fifth, let's say 5x to the fifth, and 3x to the fifth. They essentially have the same rate as x to the fifth because the 5 and the 3 here does not affect in the rate. We just do very simple math. We just take the limit as x go to infinity and we just divide them. X to the fifth cancel and we have 5/3 because they have a constant, so they have comparable rates. And to denote comparable rate, we will use this symbol. Yeah, like the hashtag. Again, the comparable rate, we use a hashtag, and the coefficient or the scalar multiplication, scalar multiplier, does not affect in the grade. That's the first one. Number two, if we have the sum or difference, only the fastest term will determine the rate in a sum or difference. Only the fastest term determine the rate. To give you an example, let's say we have 5x cubed plus 2x squared plus 15x. Okay, so all of them go to infinity when x go to infinity. But in this, the 5x cubed is faster than the cube. X cubed is faster than x squared, faster than x. So in this case, we can say this actually, the 5x cubed is, let me just write that, 2x squared plus 15x. This will have the compatible rate as the highest, the 5x cubed. The 2x squared and the 15x does not matter because those two have slower rate. And essentially just x cubed, the same rate, x cubed, because the 5 does not affect in the rate either. Right, so we just write they have comparable rate, or we can say because the 5x cubed is faster or grow faster to infinity than the 2x squared or the 15x. Yeah. So because 5x cubed is faster, the other two do not matter. Okay. And so those are two important things. But the most important thing is actually how do we rank them, and the rank will be as follows: the log, the power, exponent, and then the tau function. So here is the actual ranking. We start from log. Say logarithms will be slower than the power or polynomial, and power will be as x to the p, and that's slower than exponential. And which is b to the x, and then that will be less than x to the x, which is the tau function. Okay, so we have that ranking. So that's very important. And also in the power is this. Note that the power has to be positive, because if it's negative, well, we'll talk about that. But the base, the power have to be positive. And this for exponential b to the x, the base have to be bigger than 1. What happens if less than 1? Well, we'll see. And within this, the bigger the power, the faster. And with this, the bigger the base, the faster. Let me write that out. So this bigger power is faster. So we classify all of that under the umbrella of the power. And then over here, exponential is that. And we say bigger the base is faster. The base, of course, is the b. All right. Okay. So we have that. So that just a summary of what we need to pay attention on the growth rate of this. Now let's look at our problem. So we have 16 functions here. So let's just classify. Okay, so we look for the logs, because log is the slowest, and we'll work on those first. And I like this exercise, not just have, of course, the problem itself, but it is a very good review of algebra, and we learn a lot of all the things in this exercise too. So first, we look for the log. We're going to write out all the log function, and let's say the log. So there's a ln of x, that's a log. I just write down first, number 1, we have logarithm. We'll write out ln of x log base 3 of x ln of 5x and ln of x squared. Okay, so those are the functions that have log in it. Of course, we might also have the ln of x squared. So this guy ln of x squared, of course, is going to be faster than ln of x. But this is different. Okay. So let's rank them. Like I said, when after this exercise, we'll review important properties, important algebra formulas, and properties. Right. So ln of x. Okay, that's ln of x, just ln of x. So what is log base 3 of x? So ln of x is just ln of x. We're not going to do anything with that, but just leave it like that. Log base 3 of x. What can we do for that? Now, we don't usually use this much in calculus 2 or calculus in general. Is the change of base formula. We can change from any log of any base. Let's say this is base A. Let's say x. If we want to go to base B, just move my face cam somewhere else. Let's put that there. Okay. Just put that there. Okay, log base 3. And so we go from base A to base B of x of the argument over log base B of A. And so we go from any base to other base. But usually we just use ln of the argument over ln of the base. Of course, you can also use the common log base 10, but let's just stick with ln. Okay, so this is change of base formula. We don't use that a lot in calculus unless we try to prove something. And so in this case, for this, we write log base 3 of x as ln of x over ln of 3. Now with that, you can write 1 over ln of 3 times ln of x. Now as you see, these two functions will have compatible rate because this is a constant. So it's just like the scalar multiplication or constant coefficient multiplied to it does not affect in the rate. This is a constant. Constant multiplied to a function does not affect in the rate. So like that. Okay, so these two have comparable rate. How about this? Log ln of 5x. So this will have a product. And so for the log, we have 3 properties of the product as follows. So ln, just use ln of m times n. Or actually, we should keep things in general as log of any base of m times n is equal to log base b of m plus log base b of n. Okay. If we divide, it will be subtract. And if we have power, we can take the power outside. Okay, so we have those. Again, this formula will be useful in calculus. If you don't know that, then it will be a little more complicated. Probably you will still be able to do the calculus problem, but it will be a little more complicated. Okay, now here's the product. So this is just ln of x plus ln of 5. Now ln of 5 is a constant added to this. So pretty much this one ln of 5 does not have a growth rate because it is a constant. It does not grow. So and ln of x grow to infinity. So pretty much this we can say Okay, that constant doesn't do anything, and we can say this is compatible rate to ln of x. So after all of this, these three functions have the same rate, have the compatible rate, I should say. Okay, f of x squared, ln of x squared. Okay, here you see that we can use these properties and bring down the exponent. And we have 2 ln of x. Okay, now this is a constant multipliers, therefore there's not effect in the rate. The two they are not, there's an effect in the rate. So 2 ln of x the same as ln of x squared will have compatible rate with ln of x. So when all said and done, all of these log functions have compatible rates. So let's write the result. ln of x compatible rate with log base 3 of x compatible rate with ln of 5 to the x of 5 times x, sorry, and ln of x squared. Those all those functions have the same rate. Okay, so that's the first one. We group all the logs. Okay, so that's the first step. Next, let's look at all the logs. Now look at the power. So the power will include all the polynomial include in this. Yeah, not that, that is exponential, not that. Okay. This. That exponential also. Actually, this has the power. Where's square root of x? Well, square root of x, you can write that as x to the 1/2. And that is a power as well. So with that we have power is 1, 2, 3, and 4. So class number 2, we have powers for x to the b, x to a power. Let me write out this function. X squared minus 3x plus 1 square root of x 0.2 x cubed and x to negative 2. Okay, now let's look at each one of them. They'll say, wait a minute, I just say the power is positive, of course, but what happens if we have negative? Now, let's look at this first. We have x squared minus 3x plus 1. Well, only the one with the highest power, the fastest term, matters. So in this case, we say this is the fastest term, and that determines the rate. So we say this is compatible to an x squared. Coefficient, if there's any, does not affect it at all. Square root of x, we can write that as x to the 1/2. So with that, we say x to the 1/2. Because x to 1/2 and x squared will be faster than x to the 1/2. We have the growth rate for those two. Okay, now 0.2 x cubed. The constant multipliers does not affect in the rate. 0.2 does not affect in the rate. So essentially we say this is compatible to x cubed. Then you can rank them. Okay, x cubed is the fastest, and then x squared, and then this. But what is this? Okay, so just want to write some nice properties. In general, if we have x to the m to the n, it can be written as x to the m over n. So that nice properties, of course, very important in calculus. We need that to easily evaluate derivative, integral, and other things. Okay, so that properties. Now what happens if we have negative exponent? So if we have x to negative base, negative exponent, sorry, we can move that to the bottom. Have become that. So these two properties are very important in calculus. Not knowing that, almost impossible to evaluate the derivative or integral. Right, so we can say it, okay, x to the negative 2 is equal 1 over x squared. And then here we say, sorry, I have to move the face cam somewhere. I'm just gonna put it off for now. That's not really important. Okay. Okay, 1 over x squared. Now the roll rate defined to be limit as x go to infinity. So always the roll rate is when it go to infinity of a function. That give us, of course, that will be equal to infinity. But how fast it is the roll rate. So in this case, we say if x go to infinity, we have 1 over infinity, and that go to 0. So we say go to 0 as x go to infinity. So with that, of course, that does not have the growth rate, because that does not go to infinity, it go to 0. So in this case, we'll almost cross that out from the list. So we said, okay, this will not have the growth rate. Okay, I just want to cross that out, because that doesn't even have the growth rate. Keep that. And now we write within that we can rank the rest of this function. Okay, square root of x is the slowest because the exponent is 1/2. And then we have the x squared is this. And then we have that. So that is the class of a power function. Now let's take a look at exponent. Number 3 will be exponents. Exponential function, which is some base to the x power. Okay, now let's see what do we have. This is probably the most. So we have this e to the 2x, 3 to the x, pretty much the variable on the exponent. Therefore, exponential function e to the x squared, 5e to the x to the 4th. This is also in that category. This is tau function. This is the fastest, maybe. And then this. So, of course, the sin x is the wave. Because we talk about that later too. Okay, exponential. Let's write down what do we have in exponential function. Okay, e to the 2x, 3 to the x, e to the x squared. Okay, 5e to the x to the 5e to the x plus 4, 0.5 to the x, and 3 times 2 to the x. Okay, so there'll be 6 of them. Okay, now let's rank this. So the baseline of this is e to the x. Now, look some properties of exponential function. Like I said in this section, in this exercise, review a lot of nice formula. So if we multiply two things with the same base, we simply add the exponent. And if we divide, we subtract. And power to another power, we multiply. Usually we can go from the left to the right, but we can go from the right to left in this equation. So pretty much every formula, every equation, we can go from one side to the other. Doesn't matter left to right or right to left. Okay. Now, I look at this. E to the x squared. Well, e to the x squared. I'm sorry, e to the 2x. E to the 2x first. E to the 2x. I will use these properties. I'm sorry. These properties, and we can say this is e square and then to the x. Yeah, so these properties from right to left. Yeah, just 2 times x, so e square and then x. Now, if this is the case, we can say for this problem, the base is e square. What is it? E square equal to 7.38. Okay, so that is 7 point something. 7.4 about. Okay, so that. Next, 3 to the x. Well, this is obvious. 3 to the x, so the base is 3. And that base 3, of course, is smaller than this. So the function e to the 2x is faster than 3 to the x. E to the x squared. Well, this is... What is that? Well, x squared, how can we write that? Well, x squared is x times x, right? And in that case, apply this formula from right to left. So we have this function. Well, this is actually, we cannot say the base, because the base here is going to be a constant. Well, this base is not a constant. As a matter of fact, this is e to the x go very fast. So this actually, if you compare this to the tower function itself, this is even faster than the tower function. Why is that? Because you see, the x exponent will be the same, but the base e to the x is bigger than x, right? E to the x is bigger than x because exponential function is faster than the power. E to the x is faster than x. Oh, by the way, we can also graph. This is the x, y equal to x. We can say that as a power. The log is the smallest, and exponential function be faster. So the exponential function will be faster than this, faster than power, faster ln. So we can use the graph as well. E to the x exponential function increase fastest to infinity, and then we have power, and then the log is the slowest to infinity. But regardless, e to the x itself is bigger than x, it's faster than x. So all things being equal of having the same exponent, e to the x is faster than this. So we found the fastest term of all of this, because that is even faster than the tower function. But we're going to take this out of the list because that is not in the exponential function. Okay. We have 5e to the x to the fourth. X plus 4, sorry. Now, for this, we can write as 5e to the x, and we use these properties from right to left. And then we can group on the constant in front. And now this is a constant. A constant multiplier does not affect in the rate. So we say this is just the same as e to the x, which has the base of e, about 2.7. So that. And then 0.5 to the x. 0.5 is like 1/2, right? Actually, it is 1/2. So we can say the power goes to the top, the power goes to the bottom. 1 to the x is still 1. And now, if x goes to infinity, a finite number over infinity is 0. So this go to 0 as x go to infinity. Because it goes to 0, it does not have the growth rate. So again, we're going to take this out of the list because that does not have a growth rate. Just like the x to negative 2 does not have the growth rate. 0.5 to the x does not have the growth rate because it does not go to infinity. Okay. And then we have 3 times 2 to the x. The constant multipliers do not affect in the rate, so this essentially has the same rate as 2 to the x, comparable rate as 2 to the x, and the base is 2. And when we rank them, we rank with the one with the base. The slower the base is, smaller the base is slower. So we start from 2, 2.7, 3, and 7.4. So we rank like that. Only 4 of this has classified in an exponential function. Right. So, oh, by the way, I also forget that if we write this 1 over 2 to the x, we can write 1 over 2 to the x using that property is equal to 2 to the negative x. So that also the case. You might see that 2 to the negative x, which is the same as 1 over 2 to the x power. But again, this does not have the row rate. Okay, just want to say that. Okay, now the row rate base 2 is the slowest. And then base E, this guy. And then base 3. And then e to the 2x base e squared. Right. So that is the exponential function. We have those 3. Okay, what else do we have? Okay, the sin x. Sin x is the wave. It is between 1 and negative 1. So the sin x does not go to infinity, therefore does not have the row rate. So the sin x is not. And then we have the tau function is the fastest, almost the fastest in this list. But we have e to the x squared is the fastest, faster than even the tau function. And then pretty much with that we can write as a conclusion. So after all of this, let's rank them. First, on the log, we have this 4 function. So, oh, by the way, Let's look for the one that does not have the row rate. Okay. So we rank these three functions, and then the tower function, and then say zeros. Those does not have row rate, or does not go to infinity. Those will be the slowest. Or will not even rank them. So you have sin x between -1 and 1, therefore does not go to infinity. So that, and then no, in the log, in the power, we have x to -2. Of course, we don't have that. So we're not saying they have comparable rate, but we said not go to infinity. So x to -2. That doesn't count. And then in exponential function, we have the 0.5 to the x. So those functions do not go to infinity. Okay, let's put all together as a conclusion. So first, by the way, there's 16 of them. Let's just count. Rank the first three, these three functions. Does not go to infinity. And then next, we have the logs. So I'm just going to write all the logs here. All the logs actually have compatible rate. Yeah. Log base 3 of x, ln of 5x, and ln of x squared. Okay. All of that have comparable rates. So that is the thing that does not go to infinity, and then the slowest. The next will be the slowest, the ln. Next, the power. We just keep going, but we just keep going. So rank like that. And then next we have the power, and the result for the power is we did earlier. We have square root of x squared minus 3x plus 1, and then 0.2 x cubed. That's all the power. And then for exponential, we have that. Okay, so yeah, so keep going, increasing, and now we have this 3 times 2 to the x to e to x plus 4, 3 to the x, and e to the 2x. Okay, and after that, the tower function. But even then, the tower function is not the fastest. The fastest in this, all of this, is e to the x squared. So let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yes, so that all 16 of them will be in that order. So I think this is a very good exercise. We review a lot of important things in algebra, and that will help you in your calculus courses. Thank you for watching.